So good morning everyone. Today we are going to discuss on the satellite navigation system. So we have observed that various animals and birds, they do migrate from polar regions to various parts of the world. So even the birds and the animals, they have their own senses to get the direction and do the movement or do the navigation as per their requirements. So human beings also, we need to migrate from one place to other place or do navigate for our work or pleasure when we are making different trips. So there is a basic requirement of origin and destination, we can say, wherein we do move from one place to another place. So in this line, the different techniques help us, like the surveying and so on. So here satellite navigation is one of the technique which help us in the navigation throughout the globe. Our ancestors, they have also been doing since thousands of years the movement in the ocean. That also is happening because of the ability to find the direction. So that was in the primitive stage initially, because till the good clocks were invented, finding correct latitude was a bit challenging. However, the latitude computations were quite good with the help of the celestial navigation. So currently we are very comfortably able to do the navigation in ocean, wherein the satellite navigation is also part of it, and even the Indian regional navigation satellite system is also certified for travel in the ocean, in the Indian Ocean region. So as part of the migration activity, we are extensively using the satellite navigation technique by installing the GPS or the GNSS on the aircrafts and other vehicles. As part of the exercise of the map, which is also required for the movement or the navigation, the satellite navigation gives such a very good control. Basically, it provides us the framework for the map projection and computation of distances or the elevation based on certain datums. So here in the case of the satellite navigation, we are using the WGS84 datum as the reference datum, because that is the best fit curve we are currently using for the Earth. Also, for various applications such as the flight operations, the International Civil Aviation Organization, they are framing the safe T parameters through the standard operating procedures they form, so that the flights can move all around the globe in a very safer way. So we can see that currently we can use the various satellite based augmentation systems along with the GPS all over the globe, and we can do navigate using the flights. Even various other applications like the NSE, BSE and other stock exchanges, they are also using the various time parameters from the GPS. So they have standard parameters wherein they are using the time derived from the satellite based means, actually, because the GNSS satellites, they are also acting as the timing laboratories, because on the GNSS satellite we are using the atomic clock, which are very accurate. Today the navigation has become very common, because almost all the new cars wherein we are getting the navigation facility with the help of the GPS chip, which is installed in the cars, and there is a dashboard wherein you can feed the origin, which is your own location, to the destination, and it will generate the shortest path which you can choose. So that facility is also being widely used by all the user community, even if many times they may not be knowing about the GPS much, but they know that it gives us a location and it helps us in the navigation. Now, if we have to understand the working principle of GPS, primarily what happens that in case of the GPS, the signals are coming from the satellite, they begin from the satellite at time t1 and they arrive at the user receiver at time t2. And this travel time, when we multiply by the velocity of light, it provides us the pseudo range, that is the distance between the satellite and the receiver. When we receive such 4 signals from 4 satellites, then we are able to give a mathematical solution for the position of the receiver. So that is basically the principle. We also refer to it to as the one-way ranging principle, because signals are only received by the receiver. A receiver do not send back any signal, so it is a one-way ranging principle. In this, we are using the right-handed coordinate system, wherein the x-axis is from the center of the earth towards the Greenwich meridian, and the y-axis is perpendicular to that, and the z-axis is perpendicular to the xy plane. So it is a right-handed coordinate system which is being utilized in the GPS. So this provides us in geographic coordinate system the latitude, longitude and the altitude, whereas in case of the UTM coordinate system we get the values in terms of the meters as per the units in the UTM, Universal Transfer Mercator Projection. So different applications, they use either UTM or the latitude longitude system as per the benefit to the particular application. So here, as we discussed, in the case of the satellites we have atomic clocks, whereas in the receiver we have the quartz clock. So what happens that the accuracy and the precision of the two clocks has a synchronization issue, because they have different accuracy, different precision. So there is a fourth unknown parameter which is called the clock bias. So the problem which get crystallized is like this, that we are interested in 4 parameters, basically the position of the receiver, which is defined by the longitude, latitude and altitude, and we have to resolve the clock bias also. So the fourth unknown parameter is the clock bias. So to resolve these 4 unknowns, we need to build 4 equations from the different satellites, and these 4 equations are further utilized for generating the coordinates of the user, and that happens by resolving the x, y, z and the clock bias. So like this, using the pseudo ranges. So as I have explained, so the travel time multiplied by the velocity of light, that provides us the pseudo range, and this is the pseudo range. So this is the satellite coordinates for S1, S2 and S3 as shown here, and this is the pseudo range. Okay, this distance is the pseudo range. We call it a pseudo range because pseudo means false, and there are certain errors in the computation initially which need to be corrected. So if we have the ephemeris data of 3 satellite positions, ephemeris is nothing but the coordinates of the satellites which are coming in the signal which is received by the receiver. So on intersection of 2 such spheres we get a circle, and on intersection of 3 we get the solution for the position. However, since clock bias is also there, we need 4 signals instead of 3. In an ideal condition, 3 would have resolved if the clock bias issue would have not been there. So even the regional systems as shown here, even the regional systems earlier, they also used to provide the 2D navigation like the cyclone and the transit systems which were developed by the Russia and the US during 1960s and 70s, because in that case what was happening that they were using the transit and cyclone system for many of the oceanic applications, where if they get a 2D solution that was sufficient, because they were using less number of satellites, and Z can be assumed to be as the mean sea level. So 2D solutions are also sufficient for certain applications. However, we need the 3D solutions, and for which we need to utilize 4 signals and get the position of the receiver. So I hope the working principle is clear. So primarily I will again summarize that what is happening, that it's a one-way ranging principle system where the travel time of the signal multiplied by the velocity provides us the pseudo ranges for the various spheres, and these spheres intersect in a point, providing us the position of the user or the receiver. So two terms which we use widely here, one is the ephemeris, another is the almanac. So ephemeris provides us the coordinates of the satellites, and the almanac provides us the chart of the satellites. In general, the almanac refers to the chart of the heavenly bodies, natural heavenly bodies. But in case of the GPS or the GNSS, the almanac consists of the position or the predicted positions at certain time for all the satellites in the constellations, because the ephemeris data will be referring to the satellites from where we are able to get the signal. So that may be some limited satellites at a point of time, but almanac will provide us the position of all the satellites in the constellation of the GNSS. So it may belong to GLONASS, Galileo, BEDO, any of the systems which are giving us the global positioning. So here the time of arrival is the important thing, which is taken by the quartz clock, and the time of starting of the signal is from the atomic clock, which comes from the satellite signal. It is embedded in the signal actually, and this will provide us the user location. So during the travel, there are a lot of signal delays in the ionospheric region, tropospheric region, and thus we call it a pseudo range instead of the range. In surveying, actually, the distance is referred as the range, but in GPS, the range we are defining as the pseudo range to build in understanding that the range which we are computing initially, it need to be corrected. These are the four equations as I was talking. So this is the user position on the earth or where the receiver is there, and this is the satellite 1 whose signal is received by the receiver. The signal has the ephemeris data from where we are getting the location coordinates of the satellite. So x1, y1, z1 are known. Similarly, the x2, y2, z2, the location of the second satellite is also known. The location of the third satellite x3, y3, z3 is also known through the ephemeris data, and similarly for the fourth also. During the travel, they pass through the entire space between the receiver and the satellite, and they get delays in the ionospheric region and the tropospheric region, which also need to be corrected in the processing time. So now we have another parameter which is called clock bias, as I have told. So this is B is the clock bias. So now the P1, that is the pseudo range, is known through the time of arrival and time of starting of the signal. So P1 is, we can say it is C delta T1. So C is the velocity of light and delta T1 is the travel time for the signal from this first satellite. Similarly, C delta T2. So delta T2 is the travel time for the signal for the satellite 2. So like that, P1, P2, P3, P4 are known in these four equations. Similarly, the x1, y1, z1 for the satellite 1, x2, y2, z2, x3, y3, z3 for the satellite 3, x4, y4, z4 for the satellite 4. These are also known parameters through the ephemeris data. So what remains unknown here is the user position. User position is provided by the x, y, and z. So if we see now in this set of four equations, we have the user position unknown, that is the x, y, z, and the clock bias. So these four parameters are unknown, and thus we have made four independent equations for the solution. Now these are the nonlinear equations, and these can be resolved very efficiently using the computers, and four unknowns with the four equations, independent equations, we can resolve the parameters. So we understood that time is one of the important parameter, and that time is obtained through the use of the atomic clocks. Now time also depends in the different zones, different systems are there, which also need to be taken care during the handling of the GNSS, because timing is a science in itself, and based on the sun and moon calendar and various timing methods, we have to choose and implement them with all the corrections. So in case of the GPS, here is the atomic clocks. So here the time which we are using in GPS, it starts in 1980, 6th January, night 12 o'clock. So that is the time for the GPS to start actually. So it is the starting time for the GPS, as there are different times for various calendars. And this timing is a bit different from the universal coordinated time. So there is an offset which is taken care by the agencies, and the general user need not to worry about it. So this time is also not obtained from one clock only. It is an ensembled time. So like in case of GPS, what is happening that there are around 200 plus clocks which are actually integrated. Integrated means we obtain the time from those 200 clocks which are placed globally at different locations. They are atomic clocks, and mathematically and statistically those times from various clocks are resolved into a single value, and that single value is used as the time from the atomic clock. So it's an ensembled time. Now with the invent of the pocket digital assistants and the smartphones and the digital devices, it has become very easy for us to do the navigation and get our coordinates using the satellite datasets for various applications. Now we can see what is the status of the satellite navigation currently. So there are regional navigation satellite systems which provide services in a limited region. So like the Navik or the Indian Regional Navigation Satellite System, which is developed by India during 2013 to 2016. So there are 7 operational satellites in it, and they provide the timing, navigation, positioning services, or we can say the PNT services, all across Indian landmass and 1500 kilometers beyond Indian landmass or the borders. So that is the footprint of the IIRS. So however, it is not global. Similarly, Japan is also having quasi-zenith satellite system, which is also a regional system. Besides these 2 regional systems, 4 systems are global in nature. So one is the Navistar GPS, which is developed by the USA. It consists of around 30 satellites because of the maintenance of the large redundancy in the systems due to its importance and dependency. Then about 24 to 27 satellites are maintained nowadays in GLONASS by Russia. It is also a global navigation system providing the services all across. And similarly, the BEDO has also been completed in 2020. So these 3 are fully functional global navigation system, whereas the Galileo, the 4th one, which is under development by European Union, is also partly operational, but full operability has not been attained as of now. So it is also going to complete its constellation. So in nutshell, we are having 2 services for the regional navigation satellite systems, NAVIC and QZSS, quasi-zenith satellite system, whereas 4 services are there for the global navigation satellite system, out of which 3 are fully functional, 1 is partly functional, that is the Galileo. So the GPS network, which is developed by the USA, it uses 6 orbits, and in each of the orbit minimum 4 satellites are there at any point of time. So that makes it 6 multiplied by 4, that is 24 satellites. So that was the basic configuration. Now since lot of dependency is there, so lot of care is taken care and spare satellites are put. So any point of time we have around 30 to 32 satellites in the Navistar GPS constellation. Similarly, we have GLONASS as discussed. GLONASS is a constellation which use 3 orbits. In case of GPS, these orbits are 60 degree apart on the equator. In case of the GLONASS, it is 120 degree apart on the equator. So each orbit is having 9 to 10 satellites. Thereafter, the Galileo also use a 3 orbit based system. It is also using 9 to 10 satellites in each orbit, but it is not fully functional. So they are in the process of completing their constellation. So soon they will be completing it in the times to come. Then the BDO that has completed the complete construction of the constellation. So we can see that all the satellites are moving in their orbit. So this is a bit complex design as compared to the GPS, GLONASS or Galileo. Here in case of BDO, they are using the geostationary orbit and the medium earth orbits. Around 7 different orbits are utilized for the launches of the various satellites in case of the BDO. In addition, basically there are satellite-based augmentation services also, referred mainly for the Indian region as the Gagan, which serves in the Indian region, and VAS is there in the US, CVAS in Canada, and IGNOS for the European Union. Similarly, we have systems for Russia, China also, SDCM. So what is happening in this case, the satellite-based augmentation system, the aircrafts are using these services primarily. What is happening that in real time we are using the services of the geostationary satellites also. So we have ground reference stations where we know the very accurate coordinates. So the broadcast ephemeris data from the GPS is obtained, and over the reference stations all over the globe, the computation of the errors are being done, and these computations in the form of correction parameters are sent to the geostationary orbit. So in case of the India, it is GSAT 8, GSAT 10, which provide us the correction parameters for the Gagan. In real time, the correction parameters are relayed back to the users. So like that, the satellite based augmentation system work, wherein primarily what happens that the correction parameters are sent to the user in real time. So we can see what is happening, that in addition to the GPS satellites, there is a role to broadcast the correction parameters to the user, which is taken care by the geostationary satellites. So Gagan is providing the services in the Indian region. This is the footprint for that. Here we have to take care of one thing, that when we are flying our aircrafts from one region to another region, and different regions have their own satellite based augmentation systems. So when we enter into another system, we should switch to that particular SBA system. The reason is that the far we go from the reference stations for one particular system, the accuracy decreases. Or in other words, we can say the nearer we are to the reference stations, we should switch to those SBAS systems. So that need to be taken care. So interoperability is very important in that case when we talk about the SBAS system for movement across the globe. So the ICAO, International Civil Aviation Organization, definitely recommends the use of SBAS for the aircrafts, and in particular it is very useful for shorter airstrips because the space can be utilized very optimally. NAVIC is another important contribution besides the Gagan into the GNSS system. In the space segment of NAVIC, we have 7 satellites, and we have ground segment all across India. We have reference stations, ranging stations, and we have the user segment in the Indian landmass, and the services are available up to 1500 km beyond the Indian region also. So similar to any GNSS system, we also do have the space segment, ground segment, and the user segment. And the Android devices can also use the IIRS signal. So the Map My India has developed a app for it, and the compatible mobiles will be able to navigate using the NAVIC signals or the IIRS signals. So the space segment consists of 7 satellites. 3 are there in the geostationary orbit as shown here at 32.5 degree easting. That is the slot we have in the geostationary orbit. Another one is in the 83 degree east orbit slot. Then third one is 129.5 degree easting. Besides these 3 satellites in the geostationary orbit, we have 4 other satellites which cross the equator at 55° and 111° easting. So these two orbits which are inclined around 29° to the equator, they also have time period of 24 hours with the inclination, and they have two satellites in their orbit. So these are providing the services in the Indian region, and these are devised in such a way that they provide good dilution of precision at all times in the Indian region with the help of minimum number of satellites. And the design has been prepared in such a way that for most of the time all the satellites are visible in the Indian region. So that is the advantage with the geostationary orbit and the geosynchronous orbits which are being used for the Navik system. So this is the image where we can pictorially understand the three segments. So these are the satellites in the space segment, and these are the different stations, reference stations on the ground: IRSS Spacecraft Control Center, IRSS Telemetry and Tracking Command and Uplinking Stations. Similarly, Ranging Integrity Monitoring Stations, Timing Center, Ranging Stations, Navigation Center, Laser Ranging Stations, and the Data Communication Link. So these are spread all over Indian region. Laser ranging we are using from abroad. The Indian laser ranging facility is also under development in Tamil Nadu. So in addition to the space segment and the ground segment, what for we have actually built it? We have built it for the user agencies. So users are there who are able to use it on the ground, in the ocean and in air. And besides this, we can install the IRSS or the Navik receivers on the satellites also. So this is the advantage with the IRSS. We have the independent navigation system for Indian region, providing us full independence in terms of the navigation for in the Indian region. So basically the satellite or is the spacecraft control is done from the Bhopal and the Hassan region, whereas various stations as discussed, they are spread all over India. So there's a definitely a geographical advantage linked with the satellite technology, because with the wide east to west and the north to south, it is good to have good control and connectivity with the various satellites in its region. Now the Navik system also is providing us the positioning, navigation and timing facility. So it also provides, similar to the Navistar GPS, the position, velocity and timing at any point of time. So these three parameters are very important. Position provides us the latitude, longitude and time, whereas velocity provides us the velocity with which the receiver is moving and the timing. Because in case of Navik also, we also have atomic clocks which are being utilized. So our timing is also coming from a timing laboratory, we can say. So this time what we are using for Navik is very important and very accurate. And finally what we are getting is about 20-meter accuracy on a very conservative side. If we use the IRSS services, we will see that we are getting accuracies more than 10 meter also at various times when we are surveying. However, during the worst time also we will get very good accuracies of the order of 20 meter. Normally when we survey in the afternoon time, at that time the ionospheric activities are high and we have a higher DOP, which indicates a bit poor quality of the signals. Whichever GNSS system we use, whether it is Navistar GPS, GLONASS, Galileo, BEDO, IRSS or QZSS, it is preferable that maybe we can check our observations during afternoon while processing the data. The processing softwares provide us flexibility to remove such observations from the processing. So that will provide us a better solution. A large number of applications can be there from the satellite. As we have discussed, it is providing us position, navigation, timing. So we can use it for civilian applications, we can use it for various surveying, engineering applications, mining, volume estimations. In case of remote sensing, we can use the GNSS system for georeferencing of our datasets for the 2D images and preparation of the maps like this, which are highly accurate with the help of the georeferencing. In the GIS environment, we will be able to navigate using the shortest route method, and there can be different kind of applications, the commercial applications also, wherein we can put orders for various vendors, and they can also use our own applications, our own position. If we share our position, they can do the delivery at our end for the required material. So it can be used by every person. Actually, it can be used by the pedestrian, it can be used by the various vehicles for navigation, as we have installation of GNSS chips in the different cars. It can be used for tagging, so animals can also be tagged, even whales can also be tagged for tracking their movement. Migratory birds can also be tracked for the distance, 10,000 kilometer plus distance they are traveling from the North Pole to various wetlands. So these taggings can help us in studying the movement of the birds also. Their migratory patterns can be studied. Now the recently Kavach has also been utilized by Indian Railways. So that also used GPS as one of the technology IRS's positioning system for the safety of the railways. The trackers, when they are going to the difficult areas in the hills, that time they can have the GNSS devices with them and possibly tracking devices also, so that they can send the signal to the base in case of any kind of emergency besides their general movement. So various vehicles or your packages which you send from one place to another place, they can be tagged with the devices which are enabled by the GNSS. Earlier RFID devices were there, different other methods has been used, but currently GPS is the best method to tag your packages, and you will know their position at any point of time. Now there are applications, online applications, when you see on your internet or on your mobile, you can even get the location of the different flights at any point of time. So this is an application which has been displayed here. So that means basically there is a large number of applications, and whether the person is aware or not, primarily what is happening that directly or indirectly everybody is becoming a user of the GNSS, because they are consuming various services in terms of transportation, in terms of ordering their deliveries, whatever they are getting from various agencies. So knowingly or unknowingly they are being benefited by the GNSS technology. GNSS is providing the high accuracy for the planimetric maps, that is the X and Y, and it is also providing the digital elevation models which can be assessed by GPS, and wherein the georeferencing or the satellite triangulation, aerial triangulation has been done by the incorporation of the ground control points which are attained from the GNSS surveys. So these various remote sensing datasets which are highly useful for different type of modelings, they utilize GPS very much, particularly for georeferencing of the datasets in their different layers. So GNSS is a very critical equipment which brings all the datasets which are coming from different agencies to a one standard georeferencing system, so that the pixel by pixel matching can be done in different layers, which are basically inputs coming from different departments. So the georeferencing should be with respect to one map projection system, one datum. Then only our models will become perfect. That will attain us more accurate results. So currently the GPS, which was developed as a military system initially, it is definitely contributing to the defense operations across the globe as shown here, besides the civilian applications. So the man is also equipped with different smaller devices or the GPS which can be put in their cap or watches. So GPS in general is providing a large number of applications to various users, and we should use this application very meaningfully for our solutions. Thank you.